Welcome back Excel learners. Today you will learn how to use Excel solver for optimization problems. Solver is an add-in in Excel usually seen in data tab right here. If you don't see it, you need to install it first. Don't worry, I got you covered how to install it. First go to the files, then more, options, click add-ins, then click go. Here you will see a list of add-ins here. Check solver add-in here, click OK. Then you will be able to see Excel solver right here in the data tab. So at first we will look at a simple optimization problem that doesn't have any constraints in it. Then we will move on to a more complicated problem with a constraints or criteria in it. So our first problem is right here. You can see it. Consider the function f of x equals x to the power 4 plus 8x minus 3. Use Excel to find the value of x that minimizes the function f. So our objective is to minimize the function for a value of x. You can see I have already given a value for x that gives a value for the f of x 29. I have given this function formula right here in this cell. You can see it. So in order to optimize it, go to the data tab, solver, set the objective here. Our objective is our function for a value of x here by changing the value of x here, and we want to minimize this function and click solve, click OK. So here you can see our function is minimized for a value of x of 0. So this is how you do a simple optimization problem without constraints. Next I will show you how to use constraints in optimization problem for a more complicated problem. So now we will look at a more advanced problem that has one or more constraints in it. Consider this problem right here. With exactly 2700 meter square of cardboard, we wish to construct a box that can contain a volume of V. We require the width to be double its depth. We would like to maximize the volume of the box that can hold. Which values of x, y and z fulfill our objective? Before optimizing the problem, we need to find out our objective and constraint first. So in this problem there are two constraints. Number one, the surface of available material is 2700 meter square, which follows the geometric formula. Number two, requirement of dimensions, that is the width needs to be double of its depth, that is x equals to y. You can see I have layouted our constraints right here with their respective formulas, and the objective right here in B14 with its respective formula, and the constraint values in D15 and D16. You can see I have also given some values in x, y and z, because if you don't give any values to your variables of interest while optimizing the problem, solver may give errors. So to avoid it, we give initial random values to our variables of interest. So now we'll optimize this problem. Go to the data tab, click solver, set the objective, that is our volume, to be maximized. Click maximum by changing the variables x, y and z. Now we will add the constraints. Click add, give cell reference to our constraint number 1, which is to be equals to 2700, which is the surface area of the box. Click OK. Click add again for the second constraint. Give cell reference to the second constraint, which is equals to the constraint value, that is the width needs to be double of its depth, which is D16. OK, and click solve. Here you can see solver has find out the values for us of x, y and z and the maximum volume. You can also see that the x has a value of 29, which is double of its depth, that is y. So this is how you can optimize your problem that has one or more constraints. I hope you like this video and learned a new thing. I hope to see you in the next video. Thank you for watching.